Hello, folks, and welcome to Unit 2, Linear Function. Understanding lines. Okay, we're going to talk about two main concepts today. They are slope and graphing. So if you'll get your composition notebook out and a pen or a pencil, we will begin our lesson. So we're going to start off by talking about what the slope of a line is. Well, slope of a line is also referred to as the steepness of a line as it rises or falls. In chemistry or physics, you may have heard it as the rate of change. In math, most of the time we talk about slope in terms of rise over run, how much the graph is rising up or falling, and then over the left and right, the run is the left and right. We also know that we can use this handy dandy formula, y2 minus y1 over x2 minus x1. Some of the types of slopes that you need to know that exists are positive slopes, negative slopes, zero slopes, and undefined slopes. We're going to take a look at each one of those just to refresh your memory. If we look at graph A, you can see that as the graph goes left to right, we'll read it just like we read an equation or a book. We read it left to right. It is rising. And if it is rising, we say that has a positive slope. So then we'll go to B, and if you look at that left to right, it is falling. And if it's falling, we say that's a negative slope. Letter C, there's no falling or rising. It's just straight across as a horizontal line. We call that a zero slope. And last but not least, when the graph is vertical, up and down, we call that an undefined slope. So now that we've talked about slopes and refreshed our memory on that, let's go back in time to geometry. Do you remember what parallel and perpendicular lines are? You don't need to write this down. I'll have you write a couple things down later on. But just to bring back your memory, remember parallel lines are lines in the same plane that never intersect or cross, and we represent that by drawing two lines kind of slanted. Okay, perpendicular lines, lines that do intersect, but they intersect at in a special way, and that's at a 90-degree angle, which makes them right angles. And another way that we talk about perpendicular lines and the symbol that we use is that kind of upside down capital T. So now that we know what parallel and perpendicular lines are, let's look at what they would look like on a graph. Now again, you don't need to write this down, but just pay attention and make sure you know how to do this, and then I'll give you some more examples in a minute. So parallel lines, looking at them on a coordinate plane, we would look at each line separately. So the first thing we're going to do is look at line 1 and find its slope. And then we're going to look at line 2 and find its slope. All right, let's look at line 1. I'm going to find 2 points that are nice coordinates on line 1. I see one right here at negative 2, 1. And I also see one at negative 1, 3. Now, if I'm looking at a graph, I can just use the counting method of finding my slope. How much did the graph rise up? Well, it rose 2 and it ran over 1. So up 2 over 1 would be the slope of line 1. Now let's look at the slope of line 2. I find 2 points again, nice coordinates. Those are 2 nice coordinates. And then I look at the counting as well. How many times do we go up? We go up twice, and we run over once. So again, that slope is 2 over 1. And as you can see, the slopes are the same. Therefore, they're parallel lines. They will never intersect or cross. All right, now let's look at perpendicular lines. When I look at this one, I again figure out my line 1 and my line 2 and the slopes of each one of those. So first of all, I'm going to do line 1, find or pick 2 nice coordinates. I got a nice coordinate there and I got a nice coordinate there. And I'm going to look and see how much does the graph change? What is the rate of change? Well, this graph, line number 1, goes down 1 and right 2. So down is a negative, so we say the slope is -1 over 2. Okay, now let's look at the second line. I pick 2 points again. That's a nice point there, and there's a nice point there. And we talk about what is the slope of that line. It rises up 2, and we run over 1. So the slope of that line would be 2 over 1. Now when we look and compare these two slopes and the relationship between these two slopes, I notice that this slope has a negative and this slope has a positive. Okay, the other relationship I see between these two is that their fractions are what we call reciprocals. Okay, so perpendicular lines have opposite signs and are reciprocals. So now let's take out your notes and write that information down. So what do we know again about slopes? With parallel and perpendicular lines, we know if two lines are parallel, then their slopes are exactly the same. And if two lines are perpendicular, then the slopes are opposite, and what we call opposite and reciprocal. Okay, so they're opposite in signs and reciprocals of each other. Another way of saying that is also negative reciprocals. Okay, so let's do an example of one. Is this graph, are these two lines parallel, perpendicular, or neither? Now, I don't have a coordinate plane in front of me. If I did, I could possibly use a coordinate plane, but I would want to be very careful when graphing, when asked if two lines are parallel or perpendicular. What I would always recommend is to do it the algebraic method. It's the most accurate way of finding whether or not two lines are parallel or perpendicular. So we're going to use that handy dandy formula, y2 minus y1 over x2 minus x1. All right, so when we look at line number 1, we're going to say, okay, what are these 2 points? I have 3, 0. I'm going to call 3 my x1, 0 my y1. And then -1 is going to be my x2 and 2 is going to be my y2. Then I'm going to plug it into the formula. y2 subtract y1, excuse me, that's a 0, over x2, -1, subtract x1, which is 3. 2 minus 0 is 2, -1 minus -3 is -4, and when I reduce that fraction, I get a -1/2. Okay, so in order for line 2 to be parallel, I'd need to have -1/2. In order for it to be perpendicular, I'd need the opposite, which is positive, and the reciprocal, which would be 2 over 1. So let's see what we get here. When I figure out the slope of line 2, I'm going to do the same thing, x1, y1, x2, y2. And then I'll plug 4 into y2, minus a 0 for y1. And then x2 is 3, subtract 1, because x1 is 1, and I get 4 over 2, which is really 2. And if I write that as a fraction, it'd be 2 over 1. And that would be positive because you don't see the sign. So when I look at those two slopes, I notice that they're opposite in sign and reciprocals, so they are perpendicular. Using the symbol, excuse me, using the symbol that we know from geometry would be that upside down capital T. Okay, so that is how we would find if two lines are parallel, perpendicular, or neither algebraically. Now let's talk about linear equations. Linear equations they are equations that use x and y and also graph into a straight line. So if you notice here, I have 3 different graphs and or equations, excuse me, and they're all using x and y. They'll all graph to be a straight line. We also can represent a linear function using just x and y, and remember the x equals would be a vertical line. So if I have x equals 2, I'd have a vertical line at 2. Okay, and we can also have a horizontal line where it would be y equals -2, and at -2 I would have a vertical, or excuse me, a horizontal line. So they can also be represented with one letter, but most of the time it's with two variables, x and y. All right, so what does that mean for solutions? A solution to this linear equation would be where a point, a coordinate point, x and y, will work in the equation and make the equation true. So if I've got the coordinate 5, 4, okay, remember 5 is the x, 4 is the y, and I want to find out if it's the solution to this equation, I would plug my x in, my x value in where I see an x, and I'd plug my y value in where I see a y. So my y would become 4, my x would become 5, and then I would solve and say, are these two sides equal? Well, let's see. 4 equals 2 times 5 is 10, and 10 minus 6 is 4. So both of these sides equal each other. So yes, this is one solution to the linear equation. Now, we might have one solution, but what constitutes as a graph? Well, a graph of an equation is x and y, and it is a collection of all points, x and y, whose coordinates are solutions of the equation. So not just one point, but infinitely many points. And we have to remember that the x values are the domain and the y values are the range. And we're going to be talking about domain and range a lot in this year in Algebra 2, so we want to make sure that you know what domain and range are. So if I take the graph of the last problem I just did, and I plot the one point that I know is true, this point is, again, 5, 4. That is one solution. Well, maybe I can find another solution. Well, 3, 0 is a solution. And we can keep finding solutions to this equation that I was working with on the previous slide and finding all the ordered pairs that make the graph. And when I find all the ordered pairs, or a few, it helps me to be able to draw that line. And that line basically says infinitely many points will make that equation true. And so that is the graph of a linear equation. Okay, now you also need to know about the slope-intercept form. Slope-intercept form is y equals mx plus b, and that would be, I would say, that slope-intercept form, where m is the slope and b is the y-intercept. And I'd write that pretty big in my notes, and I'd make sure that I know that slope is the number in front of the x. It does not include the x, but it is the number in front of the x. So we are going to go ahead and use this y equals mx plus b to graph a line. So let's talk about let's do a quick review of graphing using y equals mx plus b. When I look at this equation, it is not graph ready, not quick graph ready anyway. And I like to graph using y equals mx plus b. So what we're going to have to do is we're going to have to solve for y just like we did in our literal equations last week. So when we do that, we need to solve for y. So the first step would be to subtract 3x. And I get 2y equals 4 minus 3x, or negative 3x plus 4. It can be written either way. I'm going to divide both sides by 2. And I get y equals negative 3 over 2x plus 2. Now, notice that I did not write this as a decimal. We do not want to write our slope as a decimal. The best way to keep our slope is in fraction form because it tells us the exact rise over the exact run. So this is our slope. The 2 is our b, or y-intercept. So we'll go to our graph and we'll go to the y, and we will plot the 2 first. So we go up 2 and we plot our b first. And then from there we use our slope. Now this slope says we're going down 3. So we'll go down 3. And then we'll go right 2 because our run is right 2. And we can continue to do that until we have a few points. We can also go the opposite direction of -3 over 2. We can go +3 over -2. So we can go up 3 and left 2. And then after we get our points, we just go ahead and draw a line and put arrows on each side, and that will be our graph of y equals -3x plus 2. Now that's all I have for today, so hopefully we'll see you tomorrow.